Hi, I'm Adam, and this is DreamMeridian, GeoAI at the Edge. At UNICEF, I built algorithms to compute healthcare access across entire countries. Critical work, but it ran on always online cloud servers. What happens when the network goes down? Puerto Rico to Bangladesh. When connectivity fails, people die. Maria knocked out 95% of cell sites. Cascading failures, thousands dead. Cox's Bazar, Bangladesh. 1 million refugees on patchy infrastructure. Cloud tools can't reach these places. Edge AI can. Offline maps exist, but you get search boxes, not spatial reasoning. Offline LLM GIS does exist, but it needs enterprise GPUs. The gap? Plain language spatial queries on portable low-power hardware. DreamMeridian fills that gap. Natural language in, spatial answers out. Inference, database queries, graph routing, visualization, all on device. Specifically, the Raspberry Pi 5 for our powerful proof of concept. Engineered for ARM at the edge. Pi over phone because our stack needs full Linux. Every layer optimized for efficiency from the inference engine to the routing library. 8 to 12 seconds end to end, 3 to 10 watts. Let's see it. Here's the command line interface. Video feed of the Pi, that little black box on the left. SSH on the right. I'm running queries against two different datasets, San Juan, Puerto Rico and Cox's Bazar, Bangladesh. For each query, the script runs its LLM inference, tool selection, and code execution pipeline and returns the answer. 8 seconds, entirely on device. But let's add a map. Our front end, also running on the Pi. System stats on the left, CPU, temps, memory, in real time. Map on the right. Quick note, we retrieved tiles online for the demo, but the codebase supports caching tiles for offline visualization. Puerto Rico, where Maria devastated infrastructure, we asked for the nearest shelter to Munawar, and you can see the destination. The model geocoded the neighborhood, queried the database, computed the route. I can expand the raw JSON. That's the actual tool call the LLM generated. Something harder. Is there a pharmacy between Ocean Park and Puerta de Tierra? The system computes the walking path first, then searches for points of interest along it. We await the results from the LLM in real time. Blue line is the route, orange pins, 3 pharmacies found, each with walking time of the path. That's a compound query, routing plus spatial search from one natural language question. Final demo, Cox's Bazar. What can a health worker reach from Refugee Camp 5 in 15 minutes? This computes an isochron, a walkable coverage polygon from the road graph. That purple boundary is everywhere reachable on foot. Vaccination campaigns, emergency response, outreach planning, service area from a single question. That's the vision. Full stack geospatial AI on a credit card-sized computer solving real problems. Thank you so much for watching. Full source code and benchmark data available at the GitHub repository on the slide. Good day.